Our equation, the second order derivative of y plus 9y is equal to negative 4x squared plus 5. This is an example of a non-homogeneous higher order equation. And we can solve this following this general solution. Y is equal to y sub c plus y sub p. Now, y sub c is the complementary solution if this side is equal to 0, meaning our equation is a homogeneous equation here. Even if we have here our g of x being not equal to 0, y sub c allows us to use the same processes we use in solving homogeneous equations as part of the solution. Okay, so that would be the first part of our solution here. By the way, our g of x here is quadratic because that's minus 4x squared plus 5. And with that, our y sub p, the second part of the solution, will follow a certain process of solving y sub p. Refer to this express table here for trial of particular solution because y sub p is known to be the particular solution of the equation by solving the coefficients of the identified form of g of x. Looking at the third form, because g of x is quadratic, we will be using y sub p is equal to ax squared plus bx plus c. And later on the second part of this video, we are going to solve for the coefficients a, b, and c so that we could have our y sub p that will be added to our y sub c to form our general solution of this given equation. So first, let's start with y sub c. As mentioned, we are going to use the same process of solving the equivalent homogeneous equation if we assume that the g of x, or the right hand side, be equal to 0. So we will be having this form, the equation with differential operator d. Hence, we will have here d squared plus 9 times y is equal to 0. Together with that, our auxiliary equation, f of m equal to 0, is m squared plus 9 equal to 0. This time, we are going to solve for the roots of this given auxiliary equation, and the y sub c form, or general solution for y sub c, will be dependent on the type of roots that we could come up, whether they are real or not, or imaginary, or whether there are repetitions. Once we move 9 on the other side, we will have minus 9 here. We take the square root of both sides, we will have plus minus square root of negative 9. Obviously, our roots here are actually in the form of imaginary. Moving further, because we need to have the actual values for a and b later on as part of the solution, we will have negative 1, let's start with 9. 9 times the square root of negative 1. Hence, our m is plus minus, or the roots of this given auxiliary equation is equal to plus minus 3i. Following this format for our imaginary roots, a plus minus bi, our a is 0 since we don't have coefficient here, but our b is 3. We need this because the general solution for our roots being imaginary follows this idea: e to the power of ax times c sub 1 cosine of bx plus c sub 2 sine of bx. So our y sub c is e to the power of 0x times c sub 1 cosine of 3x plus c sub 2 sine of bx. This is equal to 1. Finally, our y sub c is c sub 1 cosine of 3x plus c sub 2 sine of 3x. This is our y sub c. Okay, let's proceed to solving y sub p. And again, we were going to use this as indicated to our table presented earlier for our y sub p equal to ax squared plus bx plus c. We're going to solve for the coefficients a, b, and c. And how do we do that? We need to refer on our given equation here because we will be substituting y sub p to y and the derivatives of y sub p to the derivatives of y here. Since our y has highest degree of 2, or the degree is 2, we need to come up with the second order derivative. The first order derivative, this is 2a x plus b, and derivative of constancy is just equal to 0. the second order derivative, and again, we end up here because that's our highest degree here. So you will have 2a, and the derivative of b is just 0. With this, we can plug this in on the original equation. Let me rewrite here. Minus 4x squared plus 5. Plugging this in instead of y double prime, or the second order derivative of y, we'll be using the p plus 9 y sub p. We don't have the first order derivative here, is equal to minus 4x squared plus 5. And with these values now, our second order derivative is just 2a plus 9 times the second, the y sub p is ax squared plus bx plus c. This is equal to negative 4x squared plus 5. We just need to arrange or simplify the left-hand side for further process later. So you have 2a plus 9ax squared plus 9bx plus 9c is equal to minus 4x squared plus 5. Then we will have here, rearranging the terms, 9ax squared plus 9bx plus 2a plus 9c is equal to minus 4x squared plus 5. We are doing this because to retain the equality, that would mean that whatever would be the terms having x squared on the left-hand side should be equal to the right-hand side. Whatever would be the term with x should be also equal to whatever it is on the right-hand side. But since there's no x term here, automatically the x term is 0x. Okay? And then the constant here should be equal to 5. So we have three different equalities here. First, 9ax squared is equal to negative 4ax squared. Okay? Sorry, there's no a here. X squared. So by solving a, we can divide both sides by 9ax squared. 9ax squared, of course, that will be removed. So you will have here a is equal to negative 4 over 9. That's our a. Now for our b, since 9bx is equal to 0x, or simply is equal to 0, our b is automatically 0. We have this because we don't have here an x term. Then, let's move to our last. 2a plus 9c must be equal to 5. Since we already have this a here, so simply substitute that. 2 times minus 4 over 9 plus 9c is equal to 5. So this is minus 8 over 9 plus 9c is equal to 5. 9c is 5 plus 8 over 9. So you will have here 9c is equal to, that's 45 plus 8 is 53 over 9. Multiplying both sides or dividing both sides by 9c is 53 over 81. Because we are going to multiply 1 over 9 both sides to cancel that. Okay? This is now our c. We now have a, b, and c. And let's simply plug this in to the intended y sub b. So let me use the space here. I don't know if it's still enough. So y sub b is ax squared plus bx plus c. Y sub b, our a is negative 4 over 9 x squared. Our b is 0x. Then our c is positive 53 over 81. Hence, y sub b is minus 4 9 x squared plus 53 over 81, because this would become 0. This is our y sub b. Finally, we now have y sub b. We had our y sub c earlier. For this to be our solution, simply combine them into one. Please bear with me with the spaces here. So y is equal to y sub c plus y sub b. So y, our y sub c is c sub 1, and then the b is a 3. Okay, let me write here c sub 1 cosine 3x plus c sub 2 sine 3x. That's just our y sub c plus the y sub b indicated here. Since it's minus, so you can simply have automatic minus 4 9 x squared and then plus 53. Sorry for that. Let me rewrite it again. 53 again. Sorry. 53 over 81. This is the solution of the given equation. So we were able to solve for the roots first of our equivalent homogeneous equation and then the y sub p in terms of this percentage by error table and combining them into one. Thank you very much for watching.